All right, so we're continuing with 4B.3, determining the images of multiple points simultaneously. We've done part one today. Now we're on to part two. Part two is solving systems using matrices and technology. So we've learned how to solve systems using elimination, substitution, and graphically. Now we're going to talk about matrix. And there's two methods for solving with matrices. So the first method number one, is the inverse matrix. So now we're going to use matrices to solve. So in this blank, it's going to be matrices. All right. So the uh, matrix equation is AX equals B. If you did your assignment over, I want to say 4A 6 through 7 on Savas, you would have practiced solving matrix equations. So solving matrix equation is just like any other thing. We're going to be using inverse operations, but it's an inverse matrix, okay? Because our goal is to get X by itself, right? So A is our coefficient matrix, X is our variable matrix, which is why we want to get it by itself. We want to isolate our variables, right? And B is the constant matrix. So what takes place here is we're going to first, sorry, I got to hide that form. Turn our system into a matrix. So your first matrix is all of your coefficients, okay? So my coefficients are 2, 1, -1, and -3. Coefficients done. Next, you're going to take your variables. So what is this matrix describing? It's describing X and Y. This looks familiar, doesn't it, to our linear transformations? I know. And we know that it equals 6, 2. Okay, so we know that our constant matrix is going to be 6, 2, because that's what each one of these equations equal. Okay, so that's step one. After step one, we then are going to multiply both sides by the inverse of the coefficient matrix. So this is our coefficient matrix, which is what we're calling matrix A. So this is matrix A. This is our constant matrix, which we're calling matrix B. Okay, and we're going to use technology to model them. Okay, so now that I have identified what I need to find, I'm going to put in matrix A into the calculator. I'm going to put in matrix B into the calculator, and then I need to get X by itself. So X is going to always be my variable matrix. So my variable matrix is going to be by itself. To get by itself, I have to multiply by the inverse of A. Inverse operation. You see that? And again, we're going to do it all in the calculator, and I'm going to show you how to do it in the calculator. So I'm going to grab my calculator. I'm going to go, and I will model this since you're at home using Desmos, or in case you're working from home. So I'm going to put in my first matrix. So I'm going to clear it all, clear all. I'm going to make a new matrix A. My new matrix A is going to be 2, 1, -1, -3. Hit enter. My matrix B is going to be my constant matrix. So my constant matrix is a 2 by 1. So I'm going to hit new matrix, turn it into a 2 by 1, and that gives me 6 and 2, and hit enter. Okay. I need to find the inverse of A and multiply it times. I need to find the inverse of A and multiply it times B. Okay, so that's what I'm doing. I'm going to find the inverse of A and multiply it times B. The only thing that I don't like about Desmos is that it will not stay when I need it. Unlike, good old faithful. So to find the inverse of A, there's a handy dandy little button right here. I'm going to press A, then I'm going to press inverse. And it's going to ask you want it in fraction form. You can also get it in fraction form by pressing the fraction button. Okay, so now I have my inverse of A. So the inverse of A equals that. I can also take away fractions. So for the inverse of A, we end up with matrix. With the matrix. I needed to stay, not be my friend. We end up with the matrix 6/10, 2/10, -2/10, and -4/10. Okay. Now it says we're going to multiply the inverse times B. Okay. So the inverse times B, and I will remember the order correctly, because if I do the B times the inverse, it wouldn't work, and that's not good. We need it to work. right? So we're going to now type it again. So we have A inverse times our B. And bam, our answer is 4, -2. So we have 4, -2. So the output here. So we end up with 4, -2 is the matrix, which means that XY is 4, -2, which means that our solution to our system is 4, -2. And that's how you use inverse to solve the matrix. Okay? All right, this works regardless if it is a 2-variable or 3-variable. You're still going to create your matrix. So creating your matrix, you're going to, again, your coefficient matrix is going to be your matrix A. So this is my matrix A. And it's all of my coefficients. Remember, if a coefficient is missing, we put a 0 in it. And if a variable is missing, we put a 0 for its coefficient. This time, for my variable matrix, I have X, Y, and Z. And then our constant matrix, which is our matrix B, we now have -9, 2, and 14, okay? We're going to put them in the calculator, and then we're going to multiply the inverse of A times B. And again, you cannot do B times inverse because it will not work. So I'm going to go open my calculator. I'm going to use the clear all feature. So it's going to take away, reset everything. My new matrix for A is now a 3 by 3. So we have a 3 by 3. I'm going to put in the values. So I have -4, -5, 3, 1, 1, -1, 4, 3, and -6. Okay, there's my A. Then I'm going to put in matrix B. Matrix B is always going to be my constant matrix. So new matrix. And this time I have a 3 by 1. So I have 3 rows, 1 column. That gives me -9, 2, and 14. Okay. Now I'm going to find X. To find X, we have to do inverse of A times B. So I'm going to matrix A, but I want its inverse. And I'm going to multiply it times B. Hit enter, and there's my solution. I end up with -13, 8, and -7. Okay, so what we're doing here, again, if I wanted to write it out, so writing this out, X equals, and it's just a lot of writing. I was being a little lazy at first. So -4, -5, 3, 1, 1, -1, 4, 3, -6. But the key thing here is I'm taking the inverse of that times our B, and our B is -9, 2, and 14. When we did it, our result was, I'm going to show you again. We end up with -13, 8, and -7. So we have -13, 8, and -7. Okay, so therefore our solution is -13, 8, -7 is the solution to our system. All right, so that's method number 1. All right. Next is method number 2. Method number 2 is using reduced row echelon form. So if you choose to do method number 2, then cool, I'm recording. So method number 2 is called reduced row echelon form. With reduced row echelon form, you're going to use the method of inputting matrix to the calculator to solve. The matrix is called an augmented matrix. So what goes here is augmented matrix, or one in which we will combine the coefficient matrix and the constant matrix into one matrix. So instead of separating them, they're now going to be together. Okay. So notice here we have our system 3x plus 5y minus 7z equals -92 and such and such. Okay. And then augmented matrix, we have our coefficients and our constants, the augment all together. Okay. So they're combined. This line is optional. When you're writing it, adding this line is optional. It doesn't have to be there when you write it. Okay. Normally, you would solve this through a series of row operations because we can do this by hand. However, we're not going to do it by hand. So our goal here is to enter the matrix into the matrix A. So this time I'm going to model it using the handheld device first, because it's really easy for you to also do it using Desmos. So the first thing I'm going to do is create my matrix. This time my matrix is all of it together. So now I have a 3x4 matrix. Wake up, Sylvie. I don't know what Sylvie be doing. There we go. Second plus 7, 1, 2. I'm going to clear Sylvie out, and I'm going to put in a new matrix. My new matrix is going to be a 3x4. So I'm going to go to second, x to the -1, go over to edit. I'm going to create a new matrix A, and it needs to be a 3x4. So now there's room for me to put in 12 elements. I'm going to put in my elements, 2, 5, toodles, -7, -92, 3, -2, 5, 123, 8, 12, -1, 61. Okay, so now I have my matrix in. So I'm going to save my matrix by hitting second mode. That's going to save my matrix and take me away. Okay, now I'm going to scroll. So I'm going to go to second matrix, and we're going to go to where it says math. Notice my A is there and it's saved. So we go over to math. And it's actually faster if we scroll up instead of down. So we're going to scroll up, because when we scroll up, we're looking for RREF. Okay, RR. That's what I used to say randomly as an annoying child. This stands for a reduced row echelon form. So I'm going to click on that, and it's asking me, what am I reducing? What am I applying this to? And I need to apply this to matrix A. So I'm going to go to second, x to the -1, and I'm going to click on 1 so that I can apply this to matrix A. When I hit enter, it's going to give me a solution. Okay, so this is what I end up getting when I hit enter. Why is this called reduced row echelon form? This is called reduced row echelon form, hi Miliana, is because when you look right here, this is tic-tac-toe, 3 ones in a row. This lets me know that I have simplified this completely down. I have zeros on bottom and zeros on top. So in each row, that's my answer. So my augmented matrix here is, my reduced row echelon form. We end up with X, Y, Z. These are your X, this is your X, your Y, and your Z. So X, Y, Z is 14, -3, and 15. So your solution to the system is 14, -3, and 15. And that's how you do it, okay? Now I'm going to model it using Desmos for you. So I'm going to put Sylvia away, and I'm going to open the Desmos. I don't know why I say the Desmos, like it's a fancy place. But here's Desmo. I'm going to hit clear all, and I'm going to put in my augmented matrix. So I'm going to hit new matrix. It needs to have 3 rows, 4 columns. So I'm going to put in those values. So we have 2, 5, -7, -92, 3, -2, 5, 123, 8, 12, -1, and 61. Hit enter. And at this point, you're just going to type in RREF. RREF. Notice that it becomes bold and upright. And so parenthesis, and I need matrix A. And then hit enter. And bam, that's how you do it in Desmos. Okay. So we've learned both ways of technology to solve and reduce. So now you should be ready for your group practice, which, because we ran out of time in class, now is just solo practice, and we'll do a peer check in class. All right, if you have any questions, comments, or concerns, let me know.